A script language is a programming language that supports scripts, programs written for a special runtime environment that automate the execution of tasks that could alternatively be executed one by a human. Operator.Scripting languages are often interpreted. Primitives are usually the elementary tasks or API calls, and the language allows them to be combined into more complex programs. Environments that can be automated through scripting include software applications, web pages within a web browser, the shells of operating systems, embedded systems, as well as numerous games. A scripting language can be viewed as a domain-specific language for a particular environment. In the case of scripting an application, this is also known as an extension language. Scripting languages are also sometimes referred to as very high-level programming languages, as they operate at a higher level of abstraction, or as control languages, particularly for job control languages on mainframes. The term scripting language is also used loosely to refer to dynamic high-level general-purpose languages, such as Perl, TCL, and Python, with the term script are often used for small programs in such languages, or in domain-specific languages such as the text processing languages SED and awk. Some of these languages were originally developed for use within a particular environment, and later developed into portable domain-specific or general-purpose languages. Conversely, many general-purpose languages have dialects that are used as scripting languages. This article discusses scripting languages in the narrow sense of languages for a specific environment. The spectrum of scripting languages ranges from very small and highly domain-specific languages to general-purpose programming languages used for scripting. Standard examples of scripting languages for specific environments include Bash for the Unix or Unix-like operating systems, ECMAScript for web browsers, and Visual Basic for applications. For Microsoft Office applications, Lua is a language designed and widely used as an extension language. Python is a general-purpose language that is also commonly used as an extension language, while ECMAScript is still primarily a scripting language for web browsers, but is also used as a general-purpose language. The Emacs Lisp dialect of Lisp and the Visual Basic for applications dialect of Visual Basic are examples of scripting language dialects of general-purpose languages. Some game systems, notably the Second Life virtual world and the Trains franchise of railroad simulators, have been extensively extended in functionality by scripting extensions. In other games like Westnoth, the variety of actual games played by players are scripts written by other users. Characteristics. Typically, scripting languages are intended to be very fast to learn and write in, either as short source code files or interactively in a read-eval-print loop. This generally implies relatively simple syntax and semantics. Typically, a script is executed from start to finish as a script, with no explicit entry point. For example, it is uncommon to use Java as a scripting language because of its lengthy syntax and rules about which classes exist in which files, and it is not directly possible to execute Java interactively, because source files can only contain definitions that must be invoked externally by a host application or application launcher. In contrast, in Python it is possible to define some functions in a single file, or to avoid functions altogether and write in an imperative programming style, or even to use it interactively. A scripting language is usually interpreted from source code or bytecode. By contrast, the software environment the scripts are written for is typically written in a compiled language and distributed in machine code form. Scripting languages may be designed for use by end users of a program, end-user development, or may be only for internal use by developers, so they can write portions of the program in the scripting language. Scripting languages typically use abstraction, a form of information hiding, to spare users the details of internal variable types, data storage, and memory management. Scripts are often created and modified by the person executing them, but they are also often distributed, such as when large portions of games are written in a scripting language. History. Early mainframe computers were non-interactive, instead using batch processing. IBM's job control language is the archetype of languages used to control batch processing. The first interactive shells were developed in the 1960s to enable remote operation of the first time-sharing systems, and these used shell scripts, which controlled running computer programs within a computer program. The shell. Calvin Lewis, in his track language, is generally credited with inventing command substitution, the ability to embed commands in scripts that, when interpreted, insert a character string into the script. Multics calls these active functions. Louis Pouzin wrote an early processor for command scripts called RUNCOM for CTSS around 1964. Stuart Madnick at MIT wrote a scripting language for IBM's CP/CMS in 1966. He originally called this processor command, later named exec. Multics included an offshoot of CTSS, RUNCOM, also called RUNCOM. Exec was eventually replaced by exec2 and REXX. Languages such as TCL and Lua were specifically designed as general-purpose scripting languages that could be embedded in any application. Other languages such as Visual Basic for applications provided strong integration with the automation facilities of an underlying system. Embedding of such general-purpose scripting languages instead of developing a new language for each application also had obvious benefits, relieving the application developer of the need to code a language translator from scratch and allowing the user to apply skills learned elsewhere. Some software incorporates several different scripting languages. Modern web browsers typically provide a language for writing extensions to the browser itself, and several standard embedded languages for controlling the browser, including JavaScript or XUL. Types of scripting languages. GLUE languages. Scripting is often contrasted with system programming, as in Ousterhat's dichotomy, or programming in the large and programming in the small. In this view, scripting is particularly glue code, connecting software components, and a language specialized for this purpose is a glue language. Pipelines and shell scripting are archetypal examples of glue languages, and Perl was initially developed to fill this same role. Web development can be considered a use of glue languages, interfacing between a database and web server. But if a substantial amount of logic is written in script, it is better characterized as simply another software component, not glue. Glue languages are especially useful for writing and maintaining custom commands for a command shell, smaller programs than those that are better implemented in a compiled language. Wrapper programs for executables, like a batch file that moves or manipulates files and does other things with the operating system before or after running an application like a word processor, spreadsheet, database, assembler, compiler, etc. Scripts that may change, rapid prototypes of a solution eventually implemented in another, usually compiled, language. Glue language examples. Macro languages exposed to operating system or application components can serve as glue languages. These include Visual Basic for applications, Word Basic, LotusScript, CallScript, PerfectScript, Hummingbird Basic, QuickScript, Sax Basic, and WinRap Basic. Other tools like Awk can also be considered glue languages, as can any language implemented by Windows script host engine. A majority of applications can access and use operating system components via the object models or its own functions. Other devices like programmable calculators may also have glue languages. The operating systems of PDAs such as Windows CE may have available native or third-party macro tools that glue applications together, in addition to implementations of common glue languages, including Windows NT, MS-DOS and some Unix shells, regexec, PHP and Perl. Depending upon the OS version, WSH and the default script engines are available. Programmable calculators can be programmed in glue languages in 3 ways. For example, the Texas Instruments T92 by factory default can be programmed with a command script language. Inclusion of the scripting and glue language Lua in the T-Inspire series of calculators could be seen as a successor to this. The primary onboard high-level programming languages of most graphing calculators in many cases can glue together calculator functions, such as graphs, lists, matrices, etc. Third-party implementations of more comprehensive basic version that may be closer to variants listed as glue languages in this article are available, and attempts to implement Perl, regexec, or various operating system shells on the T and HP graphing calculators are also mentioned. PC-based C cross-compilers for some of the T and HP machines used in conjunction with tools that convert between C and Perl, regexec, Awk, as well as shell scripts to Perl, VBScript to and from Perl make it possible to write a program in a glue language for eventual implementation on the calculator. Job control languages and shells. A major class of scripting languages has grown out of the automation of job control, which relates to starting and controlling the behavior of system programs. Many of these languages interpreters double as command line interpreters, such as the Unix shell of the MS-DOS command. Others, such as AppleScript, offer the use of English-like commands to build scripts. GUI scripting. With the advent of graphical user interfaces, a specialized kind of scripting language emerged for controlling a computer. These languages interact with the same graphic windows, menus, buttons, and so on that a human user would. They do this by simulating the actions of a user. These languages are typically used to automate user actions. Such languages are also called macros when control is through simulated key presses or mouse clicks, as well as tapping or pressing on a touch-activated screen. These languages could in principle be used to control any GUI application, but in practice the use is limited because the use needs support from the application and from the operating system. There are a few exceptions to this limitation. Some GUI scripting languages are based on recognizing graphical objects from their display screen pixels. These GUI scripting languages do not depend on support from the operating system or application. Application-specific languages. Many large application programs include an idiomatic scripting language tailored to the needs of the application user. Likewise, many computer game systems use a custom scripting language to express the programmed actions of non-player characters and the game environment. Languages of this sort are designed for a single application, and, while they may superficially resemble a specific general-purpose language, they have custom features that distinguish them. Emacs Lisp, while a fully formed and capable dialect of Lisp, contains many special features that make it most useful for extending the editing functions of Emacs. An application-specific scripting language can be viewed as a domain-specific specific programming language specialized to a single application. Extension embeddable languages. A number of languages have been designed for the purpose of replacing application-specific scripting languages by being embeddable in application programs. The application programmer includes hooks, where the scripting language can control the application. These languages may be technically equivalent to an application-specific extension language, but when an application embeds a common language, the user gets the advantage of being able to transfer skills from application to application. A more generic alternative is simply to provide a library that a general-purpose language can use to control the application, without modifying the language from the specific domain. JavaScript began as and primarily still is a language for scripting inside web browsers. However, the standardization of the language as ECMAScript has made it popular as a general-purpose embeddable language. In particular, the Mozilla implementation SpiderMonkey is embedded in several environments such as the Yahoo widget engine. Other applications embedding ECMAScript implementations include the Adobe products Adobe Flash and Adobe Acrobat. TCL was created as an extension language but has come to be used more frequently as a general-purpose language in roles similar to Python, Perl, and Ruby. On the other hand, Regexec was originally created as a job control language, but is widely used as an extension language as well as a general-purpose language. Perl is a general-purpose language, but had the Perl dialect, consisting of a Perl 4 binary with Oracle call interface compiled in. This has however since been replaced by a library, DBD. Oracle. Other complex and task-oriented applications may incorporate and expose an embedded programming language to allow the users more control and give them more functionality than can be available through a user interface, no matter how sophisticated. For example, Autodesk MAU 3D authoring tools embed the MEL scripting language, or Blender, which uses Python to fill this role. Some other types of applications that need faster feature addition or tweak and run cycles also use an embedded language. During the development, this allows them to prototype features faster and tweak more freely, without the need for the user to have intimate knowledge of the inner workings of the application or to rebuild it after each tweak. The scripting languages used for this purpose range from the more common and more famous Lua and Python to lesser-known ones such as AngelScript and Squirrel. CH is another C-compatible scripting option for the industry to embed into C++ application programs.